Okay, so today we're going to learn about the history of atomic structure. We're not going to get into atomic structure quite yet. And I have another special guest.
Miss Kelly!
Yay! So you get 2 science teachers for the price of 1. See, it happened. Okay, so first you need to know what an atom is. An atom is the smallest unit of matter that retains the identity of the substance. And we looked at that on the last test a little bit. Did you?
Yeah,
guys?
we did too. Yeah.
Cool. Do you want to do Democritus?
Yes, Democritus. He was the first person to propose the idea of the atom. He said that there must be some point at which you cannot cut matter any smaller, and he called that the atom. He decided that his theory was that between atoms is empty space. Atoms are always in motion, and they can differ in size, shape, and mass. He also lived around 460 BC to 270 BC. He's very old.
Yeah, old and dead.
Old guy.
Like all these guys, but he's the oldest. And he was actually right. So everything he proposed way back then is actually correct, which is kind of cool.
Yeah.
It was like a long
pretty
time
amazing,
ago.
really.
So the next guy, John Dalton, he lived, we're going to fast forward about 2,000 years. So he lived 1766 to 1844. So again, dead. He proposed the first unified atomic theory. So he kind of took all these ideas that scientists were tossing around there and he threw them all together and was like, this is how it is. So elements are made of extremely small particles called atoms. See, he stole that from Democritus 2,000 years ago. Atoms.
They collaborated.
Yes.
He didn't steal it.
That is science.
Yes.
Atoms of a given element are identical in size, mass, and other properties, physical properties. We just took tests on that.
Yes.
Yes, you did. Atoms of different elements differ in size, mass, and other properties. So atoms of a given element are the same. If it's a different element, the atoms are going to look different. Atoms cannot be subdivided, created, or destroyed. Atoms of different elements combine to form chemical compounds. And in chemical reactions, atoms are combined, separated, or rearranged.
And he was right. Another smart guy.
They're so smart. That's why you have to learn about them.
All right, J.J. Thomson was next.
I'm kind of jealous. This is my favorite one.
I know. He lived a long time ago also, 1856 to 1940. He discovered the electron. So he proposed that the structure of the atom was some negative particles floating around a sea of positive charge. So he called this the plum pudding model. I've never had plum pudding before. So
I have. It's kind of gross.
It doesn't sound good.
It's not good.
So we like to think of it as the chocolate chip cookie model, where the cookies are positive and the chocolate chips are the little negative bits, aka the electrons.
Cool. And he was right. We do have electrons, but his model wasn't correct. The plum pudding model or the chocolate chip model is not correct. But we still give him props because he found the electron and it's super tiny. So that's
Cool dude.
Pretty cool. Okay. Ernest Rutherford. Again, dead. Lived about the same time as J.J. Thomson, 1871 to 1937. And he discovered the nucleus. By aiming alpha particles, which are little teeny tiny, it's 2 protons, 2 neutrons, mushed together. So he aimed these little particles at a piece of gold foil, and he discovered that the atoms must have a dense positive center.
Can we do that in lab?
We can. I think my class might have done it today.
Oh.
Not today, but today when they're watching
alpha
this
particles?
today. Not alpha particles.
Oh, okay.
Oh, no, they do it with marbles.
Oh, perfect.
I see where you're going.
Oh, yeah.
I missed it the first time.
We'll get used to it.
We're having too much fun. Okay, so the keywords for Ernest Rutherford are Rutherford scattering. The alpha particles bounced off the center of the bounced off the nucleus and scattered back, or the gold foil experiment. You'll learn more about him in high school. I think they still do.
So that's how he knew the nucleus was there?
Right, because stuff was bouncing back at him.
Cool.
It'd be like, the analogy is like if you fired a rifle at a piece of toilet paper and the bullet came back at you. You'd be like, what?
Yeah.
That's like how he felt.
Cool. He was right.
That's why you have to know about him.
Smart guy.
I think we're done.
Is that it?
Oh, no, one more.
Bohr.
Oh, the most important one!
Yeah, you can't miss this one. Niels Bohr.
I forgot.
He lived kind of the same time, yeah.
A little bit
1885 to 1962.
I think he actually was the grad student of Ernest Rutherford.
You know, I heard that too.
I think
Yeah.
that's true.
Yeah. So that's
We're not making it up.
I don't think.
We don't think.
All right. He decided that these negatively charged electrons circled the positively charged nucleus in defined orbits. So he built on what the other guys said with the electrons in the nucleus.
More collaboration.
Good stuff. He also determined that the electrons can jump from one orbit to another and emit or absorb energy.
And he was super right. And he's the last guy.
Yes.
For real this time. That's it.
It's been fun.
Good job.
Bye.
Okay, bye.